Okay, we're continuing our work here in Unit 1213, looking at linear equations. We want to talk about point of intersection here. So our goal is that by the end of this, this lesson here, we'll be able to find the point where two lines intersect and interpret that point of intersection and sort of talk about what it means for the situation that these lines are based on. Because we've done a lot of work over the course of this unit talking about linear relations, representing them in different forms, equations, tables, graphs, and connecting them to situations that can be modeled by linear relations. So we want to, at the ends of the problems that we're going to do here, we want to be able to talk about what the point of intersection means in terms of the situations that these lines represent. So just to start us off, whenever we have two or more linear equations that we're discussing or looking at or graphing on the same set of axes, they form what is known as a linear system. Okay, so just one line, we have a linear equation, two lines together, we have a linear system. The point where the two lines intersect is called the solution to the system. And this is the only point that is on both of the lines. So for example here, we've got the lines y equals negative 2x plus 8 and y equals 2x minus 4. The solution to this linear system is, well, it's the point where the two lines intersect right here. What is that point? It is the point 3, 2. So the solution is the point 3, 2. And that's what we mean by solution to a linear system. Okay. So let's take an example here. If we want to solve a linear system, what we have to do is graph both of the equations and find the point of intersection. So in our first example, we have find the solution to the following system. Y equals x minus 8 is our one equation, and y equals negative 1/2 plus 1. And we want to graph both of these lines on this grid that we have over on the right and find the point of intersection. Now, how are we doing this? Well, let's look at our first equation, y equals x minus 8. And we know from our work on linear equations that the rate of this line is going to be 1. Okay, because, well, we don't see the 1 in there, but we assume that there's a 1 as the coefficient on that x there. So our rate is 1, which is our rise over our run. So our rise must be 1 and our run must be 1. So that means our line, every time we go to the left 1 square, we're going to go up 1 square as well. And our initial value, we can also get right from that equation, is going to be negative 8. That's our value right in here. So that value tells us where this line sort of starts. So we know right away that this point right here at negative 8, 0, negative 8, is going to be one of the points on our line. And then to graph this thing, we know that we have to go, well, our rise and our run and then our rise. So over 1 and up 1, over 1 and up 1, and so on and so on and so on. So we can put a graph, we can put a line on there. We're going to have to start right there at negative 8. And we're going to make this so that it goes over 1, up 1, over 1, up 1. And I'll make it go a little bit further there. So there is our line. Y equals x minus 8. We'll just label this y equals x minus 8. All right, what about our second one here? Y equals negative 1/2 plus 1. Well, for this one, the rate is negative 1/2, which of course is rise over run. So this means that our rise is going to be negative 1. So it's going to be going down as we go from left to right. And our run is going to be that number off the bottom. It's going to be 2. So if we go over 2, we have to go down 1. Over 2, down 1 in order to graph. And our initial value is positive 1. So this line is going to start right here at positive 1. And if our run is 2, it's going to go over 2, and then down 1, kind of like that. and then over 2, and then down 1. So we're going to take our line here, and let's get it to sort of match that trend, kind of like that. And then let's adjust this so that it goes up through that line. And then let's get it to match up those points there. So there's our second line. Y equals -1/2 plus 1. Okay, what did we want here? We wanted the solution of the system. So the solution is where these two lines intersect. So they intersect right here at the point 6, -2. So we can say the solution is 6, -2. So in this example here, we were just graphing the lines. Okay, we just had we had equations. We didn't have sort of any context for these equations. So we're going to take a look at a couple of examples now where the linear equations that we're working with represent something to do with a particular situation. And we're going to interpret that point of intersection. So here's examples. Lisa must choose between 2 contract jobs. Alliance Incorporated offers a signing bonus of $30 and an hourly rate of $10 per hour. Best Industries offers an hourly rate of $15 per hour. Write an equation for each job that relates the total earnings to the number of hours. Okay, well, let's say total earnings is E, number of hours, it's going to be N, those are our 2 variables here. For Alliance, let's see, Alliance offers a signing bonus of $30 and an hourly rate of $10 an hour. So the rate has got to be $10 per hour here. So we know that it's going to be, our equation is going to have the form E equals something times N, and then something added or subtracted. So that rate of $10 is going to go in here. So it's $10 times the number of hours, because that rate is $10 per hour. And then even if she worked 0 hours, she still gets that signing bonus of $30. So the equation for Alliance here is her earnings are 10 times the number of hours plus 30. This is our rate. This is our conditional value. What about for Best Industries here? Well, let's see. Best Industries offers an hourly rate of $15 per hour, but they don't have that signing bonus on there. So our equation is going to be E equals something in terms of the number of hours. Our rate is $15 per hour, so it's going to be 15 times the number of hours. This is our rate. And we're just going to leave it like that because there's no initial values here. We could say initial value is 0, right? Because they don't offer that that signing bonus. So she has to work a certain number of hours to actually get moving. Okay, which company should Lisa work for if she estimates each job will take 4 hours? So what this means is she can either work 4 hours for Alliance or she can work 4 hours for Best Industries. Let's see which one is going to pay her more. So let's move this down a little bit. If she works for Alliance and she works 4 hours, this means N is equal to 4. So we're going to sub that into our equation. Our earnings are going to be 10 times 4 plus 30. 10 times 4 is 40 plus 30. So she would earn $70. If she works for Best Industries, her earnings are going to be 15 times that 4. 15 times 4 is 60. So she's going to be making $60. So which one should she choose? I think she should choose Alliance because it's going to pay her more. So we could just say Alliance will pay her more. On On the other hand, which company should Lisa work for if she estimates that each job will take 12 hours? So in this case, the number of hours is 12. So Alliance will pay her $10 per hour, so 10 times 12 plus 30 hours is 120 plus 30, $150. Whereas Best Industries, on the other hand, is going to pay her earnings are going to be $15 per hour times 12 hours, $180. And then we work out there. So now, Best Industries will pay her more. Pays more. There. So if we're to ask the question, which of these companies should she work for, ignoring any of the other sort of factors when considering employment, and you're just concerned about how much money she was going to make, and so we asked, which one should she work for? Our answer would have to be, well, it depends. It depends on how many hours she's going to work. In some cases, Alliance is the better one to work for. In other cases, Best is the better one to work for. So how can we make sort of a more definitive recommendation about which company she should work for? Well, what we want to do here is we're going to find the solution for the linear system defined by these two equations. So we're going to find the point where both jobs pay exactly the same. And then we're going to make our recommendation based on that. So we are going to plot these two equations on the same axis here to solve the linear system. So let's see, we'll do one in red, we'll do one in blue, and just to make it consistent with what I did before, we're going to do Alliance here in blue. So how can we graph this line here? Well, for Alliance, we know two data points. Okay, we know that when the number of hours was 4, her earnings were $70. And when the number of hours was 12, her earnings were $150. So we can draw the line based just on those two data points. So when the number of hours is 4, earnings were 70, right there. When number of hours is 12, over here, earnings is 150, right there. Okay. And we also know one other point. We know that when our number of hours was 0, her pay was $30 because this was our initial value. Okay, so that's enough information to graph our line. So if you're doing this, you're going to take a ruler, draw that line there. I'm just going to take this line that I have right here, and I'm just going to change the endpoints. Put one endpoint right there, and then I'm going to make this go right through all of those data points, just like that. Okay. Now, I can tell the difference between my line for Alliance and Best because I'm doing them in different colors. What's helpful if you're just doing this, in pencil in one color is to label it. And I'm going to label it at both ends. So this blue line here is Alliance. I'm going to label the beginning and the ending of the Alliance graph here. Now let's graph our line for Best Industries. Well, what information do we have for Best Industries? We know that when the number of hours was 12, the earnings were $60. And we know that, when the number of hours was 4, the earnings were $60. When the number of hours were 12, the earnings were $180. So we can graph those points for 60 right here and 12, 180 all the way up there, And we had one more point. We knew that the initial value was at 0. So let's draw a straight line through those points. One right there. And adjust this one so it goes through all of those points, just like that. Okay. Now we can find our solution here. So where do these lines intersect? They intersect right here at 6 hours. Okay, so they intersect at the point 6, what's that, 690? So what does this tell us? It tells us if you work 6 hours, okay, at 6 hours, both jobs, or both companies, pay $90. Now, we want the one that pays more, okay? So if we work less than 6 hours, so if we're over here, this is less than 6, we can see that Alliance pays more because the blue line is higher than the red line. But if we're over here and we're working more than 6 hours, we want best, and I should label that line for best industries, B and B. We want to better off working for best industries because it pays more. So here is how we answer this kind of question. We want to say she should work for Alliance if the job will take less than 6 hours. Because it's going to pay more. Otherwise, she should work for best. And you want to structure this answer this way, making sure that you reference this point of intersection. Okay, you want to have that number in your concluding statement. Okay, and you want to say when one, like you always have two things that you're comparing in these kind of questions. You want to say when one of them is better and when the other one is better, making specific reference to that point of intersection. Okay. So let's do one more example of this style of question, and then you guys will be ready to do it on your own. Here's example 3. Mike wants to join a ski club for the winter season. He is considering the following 2 options. They have the standard plan, which is $50 a day. I guess that's for each day that he goes skiing, and there's no registration fee. Then there's the frequent skier package, which is $40 each day and a $100 registration fee. We are asked which plan should Mike choose. Well, we're going to follow the same process that we followed in the last one. We are going to write an equation to represent each plan, and then we're going to graph them on the same axis. So, first off, what are our variables here? Let's let D be the number of days skiing, and let's C be the total cost. Total cost. Okay. And our total cost is going to depend on the number of days skiing. Okay, so we know which one is our dependent variable. C is our dependent variable, and D is our independent variable. All right, well, let's take a look at what our equations are going to be. So for the standard plan, $50 per day and no registration fee. So let's see, let's do the standard in blue here. So standard, $50 per day is our rate, and we have no registration fee, so our initial value is 0. So what is our equation going to be? Well, it's going to be C equals 50 times D. For our frequent plan, it costs, I'm doing this in red, $40 per day is our rate. This is $100 is our initial value. The amount that he has to pay right at the beginning. So our equation is going to be the cost is $40 for each day plus that $100 registration fee. Okay. Now let's go ahead and graph this. So you should still have the equations right in front of you. D. Okay. So how are we going to graph this? Well, if we're going to graph the standard plan here, we know right away that the initial value is 0. So it's going to go through this point, 0, 0. Another good thing to do is just find the coordinates for another point that is like towards the end of your graph here. Okay, so let's pick the point D equals 20, and let's find out what the cost is going to be. 50 times 20. 50 times 20 is going to be 1,000. So we have the point 21,000. So that point is going to be 20, and then we'll go all the way up to 1,000 right here. Oh, and we forgot to label our axis. Oh, okay. This is across the x-axis. This is our number of days, okay, because there's our independent variable. And up on the y-axis here is our cost in dollars, because that's our dependent. And now let's add our line here for the standard plan. So I'm just going to take one end, put it down there, make the other end come up through this point right there. Perfect. And I'm going to label it at both ends. This is the standard plan. This is the standard. All right. Our frequent skier plan here had an equation C equals 40 for each day plus 100. We know that the initial value is 100. So that gives us the point 0, 100, which is going to be right there. And we can do the same thing that we did before. We could say, okay, if the ski's for 20 days, what is the cost going to be? It's going to be 40 times 20 plus 100. 40 times 20 is, what is 40 times 20? It's going to be 800. Plus 100, 900. So the second point that we have here is the point 20 to 900. So let's add that point to our graph right here. And take out your ruler, and let's draw our line. There we go. And we're going to label this. This is our frequent plan. So we'll label this F. And we'll label this F. Move that S up a little bit to make it a little bit more clear. Okay, which plan should he choose? Well, let's find our point of intersection. The point of intersection is right here at 10 days. Okay? So they intersect at this point 10, 500. Okay? So you have this question on your page. What does the point of intersection represent? Well, the point of intersection is 10, 500. It represents if he skis 10 days, both plans cost the same amount. They cost $500. What advice would you give Mike about choosing a plan? Well, let's see. He wants to choose the cheaper plan. So the standard plan, the blue line, is cheaper when he skis less than 10 days. The frequent plan is cheaper if he skis more than 10 days, because it's the lower line. So we want to say something like that. We could say, choose the frequent plan if he will ski more than 10 days. Otherwise, choose the standard plan. So we made a recommendation here. We've said which one is better, and like we've said, in which cases the frequent plan is better, and in which cases the standard plan is better. The frequent plan is better if he skis more than 10 days. The standard plan is better if he skis less than 10 days. So that's our solution.